I'm Keith Weber with CATI, and today we're going over big applications for large Polyjet printers. So we'll go over some Polyjet printers by Stratasys, then we'll go into the production materials, then dive right into the applications, and then end with a couple customer stories. Should be a nice, quick presentation. So to start things off, we're going to go into the Polyjet portfolio of Stratasys. If you're not familiar, Polyjet technology uses inkjet technology to put layer by layer and then cure a photosensitive resin, mostly an acrylic base. The prints, as you see in the video, it's a time lapse, as you can see, goes really fast. It puts layer by layer down, cures it with the UV, and then you're able to pull this thing off of the build tray. There's a little bit of cleaning involved, but we'll get into that in a little bit. So we offer a multitude of products from CATI that are from Stratasys. We have our office area over on the left. Granted, I'll say the Connex 3, I would almost say in the manufacturing zone. As you can tell, the Objet 350 to 500 Connex 3 is considered manufacturing. That 260 is that like middle ground where it almost makes it. So these are some larger machines we'll be focusing on, especially in the Connex 3 with the 22 base materials, triple jetting, the J750, which has Pantone certified as of recently. So now we can do a lot of color matching for branding. And then, for the largest printer, it's the Objet 1000. That's just a large format printer that has sheer throughput. So our materials are broken up into four groups. We have our general material, which is the Vero family. That's the standard stock materials you may see. Also have a rigor and duress material that are a little bit tougher and easier to work with mechanical properties. Flexible materials, we had the Tango family. Those have been getting phased out, and it's been replaced with the Agilis 30 family, which we'll go into more detail next. And then under the specialty area, I've actually worked with the Med 610 a good chunk early on in some medical research and getting some surgical guides into surgery. So that was really cool. The Vero Flex, which is I'll say an eye care family material that you can create lenses for. We'll dive into that. And then, of course, we have the digital ABS family that is known for being able to recreate injection molds for short-run production. So Agilis 30, this is a ballet slipper off the printer and then had the material dissolved away. So properties are great. So it's a complete improvement upon the old Tango. So if you look over our little stats, it is a Shore 30. It's twice the tear resistance, 2.5 times the tensile strength. It feels better. It doesn't, like when we say it looks and feels better, it isn't super glossy. It isn't super sticky. Like Tango, you could set it on your desk and then you'd have to kind of peel it off because it just stuck to everything. Agilis doesn't have nearly as sticky surface. Also has a better elongation at breaks. So those are some of the major reasons why we like the Agilis. And then it also has a little bit wider range of the digital shore value when we're mixing it with the Veros. So you can tell it goes from a 30 to a 95. The Tango had a little less, like I think it's the 60 or 70 before we didn't have using the Tango family. So now the digital ABS, as I told you, this is kind of our workhorse in the Polyjet side. This is the material we go to because it's one of the strongest we have for Polyjet. So the new digital ABS Plus is 38% more impact strength. Its prints pretty much the same, but the chemical properties were tweaked a little bit so that it goes together a little bit better. So the way they did that was just how they structure the RGD 535 and the RGD 515 and how that matrix of combining them with the print heads forms creates this new material. So using the new matrix and that, we're able to improve some of the strengths, better thin wall properties, and the like for especially injection molding. So that first entry point where that hot plastic rams into that mold, we can really reinforce those thin walls. So that's why we really like the new digital ABS 2 Plus. Here's that heat deflection versus impact strength. So as you can tell, out of all of our materials, Vero White Plus is down here near the bottom left. The high temperature materials that we have, the rigor, the other rigor and duress, are down here still at the bottom under 40. Digital ABS was our best material, and now we've only improved upon that, so we've moved that level up. And then also with the new digital ABS Plus, there is that post-thermal heat treating where you can stick it in an oven and just kind of cure it some more to give it even more heat deflection property. Now here's our little case study where we created 600 spoons, 100 injection cycles, and it withstood 100 injection cycles. Comparing our digital ABS mold, which we created in mere hours, under 1 business day for less than $1,000, compared to the aluminum mold, which had about a 30-day turnaround between going back and forth with the machine shop and then getting the estimates on the material cost as well. So it's the time savings is what we're really focusing on here. That's a 97% savings. So that's going to be your key component when implementing this. So digital ABS is compatible on our J750, our 260 and up, and then of course the big Objet 1000. And then also there's some of the legacy Connex machines also run this as well. Now we're going into the VeroFlex. This is only for the Stratasys J750. It's a unique combination of stiffness and flexibility, and you'll see with the, especially in the eyeglass world, it has some flex, it has full color, it's a really cool application. So it has been designed for the custom eyeglass industry. The idea is that we can print off custom frames that are wearable, and they are, semi-durable, but they're also, semi-disposable as well. They're not mass-produced. They have a low enough price point where people can jump into them without having to cut injection molds and running different cycle times and having a short-run injection mold all the time. You can have custom printed frames on demand in mere hours. So kind of like a lens crafter, but they're building the frames in-house as well with the lenses. So here's a picture. I like this, kind of blurry, but yeah, you can see that you can actually really bend the flexible Vero. So it does come in the 6 colors, and we'll have a full color gamut of, possibilities. Like I said, it is only on the J750. It does require all of the heads to make this material work, so that's why it's only on the J750. Now, going into, I'll say, the branding and product side of our materials, we have the new Vivid Vero line, which makes things really pop. So a lot of product development firms and big companies who are testing new products are using this to create fake products to stick on shelves. So here's some post-process shifters from the automotive industry. We have some perfume bottles that you can find in the wild, and companies are literally putting these on the shelves, seeing how customers interact, and if they go up to the register, some sort of bell or whistle goes off, and then they come over and talk to the customer of why they picked this new product. So here's a close-up of those nail polish bottles. Then here's that lens. Note this is the underside. The other side was actually not post-processed at all, and so the one side was polished and the other side was just as is. So here's a full line of different beers and perfumes and creams. And now we're going to get into the case study parts, moving parts. So one of the cool things about one of the new supports that we got is called 706. It's dissolvable, so you're able to melt it away and you don't have to peel it or grind it, which really helps your post-processing time. And we have an auto-clean system that agitates the tank and helps really remove this material for you. Next, so using that removable material, the 706, and this, we get into one of our first case studies, which was Leica Studios. If you don't know, Boxtrolls, Caroline, The Missing Link, Kubo and the Three Strings, and I think there's a couple others that they were part of, but they create stop-motion animation, and all of these items you're about to see are 3D printed. We're going to jump into a video. So in order to make the stop animation, they print off tens of thousands of faces. So I really like this slide because it shows all the different facial features between this character going from closed mouth to opening and roaring. The number of facial animations that were printed was in the just over 100,000 for this movie, and 80% of them, all they needed to do was just clean the parts, either dissolving and then going in with a toothpick, making sure all the fine details were, all the supports out of the little fur, and then they were able to use it. So they didn't have to do any touch-ups or coloring or fixing. Like, it was just, it saved a ton of time for them.
This feels very confined. I feel woozy. Do I look pale? I feel pale.
You stop fidgeting, Mr. Lake. You mustn't draw attention to yourself.
Well, I'm not very comfortable stealing a man's clothes.
Well, you can't
He
very
thinks
well
so highly of you, Lionel.
It's indecent.
Gotta get myself a grip here.
Please do not, whatever you do, mention
Bribe the port authority.
Never learn the truths of our
Human being!
And then what happened? Smells of wet dog.
Oh, that's better.
One that I wanted to show real quick, just a little clip.
Science or innovation is worth a risk sometimes to go out on a limb.
And with each successive film, we all work and grow as artists.
We really wanted to find a way to push facial animation beyond what we'd ever done before.
And the subtlety and a range of emotion.
You get totally transformed into the story and you forget that you're watching a little 12-inch puppet.
It's hands-on, it's tactile, there's a life to it that most other animation forms don't have anymore. We're a group of really talented artists who want to do it the best that we can.
Here at Leica, the energy, the atmosphere just really crackles with that creativity.
We don't have to be limited in the stories that we tell. That's what's exciting about the studio.
It feels like we really are just scratching the surface of what this art form can do. And that's incredibly exciting to me.
We're here,
So that is Leica, and one of my favorite videos is this one right here. We won't watch too much of it, but just showing you how they switch over all the faces, and then also they decorated their office with all the faces of their characters. So it's kind of fun to see, yeah, when we're saying hundreds of thousands of facial animations as they 3D print them, they were like true. Like, it's tons of these little faces that are combination into it.
And that character design was going to be impossible to achieve with our current color printing technology. And I look back on that now, and if we had chosen any of the other 3D printers...
So what he's talking about here is that, yeah, current color printing capabilities was you had to create a blank, and then you had to hand paint it and create all these things. And it's entering into this new J750 era where you can color match with Pantone colors and get real products produced off of this printer in a hurry. So that allowed them to really escalate into Kubo and then the new Missing Link series and push the boundaries of what they thought was possible. So moving on, we have our case study for the medical. This is taking a CT MRI scan, creating the 3D data, and then synthesizing it, separating it into multiple STL files, and then colorizing each individual vessel or tumor thing, and then being able to 3D print the very complex matrix of veins in the skull, and then dissolve out the support. Once again, we're really kind of harping on the support 706 because there was a lot of complaints early on of having to scrape off that kind of, waxy clay-like substance that was the 705 support. So with the new 706, we have this great ability to melt it away and make the post-processing a lot easier and cleaner. So here's a bunch of examples of, all right, this bottom right-hand corner is actually a working heart that they're practicing pumping with, different valves, a lot of segments of the different heart. Personally, I've worked on a mandibular facial reconstruction surgical guide that was done taking a CT scan of a mandible, your jawbone, and then tracing out where a tumor was in that section, colorizing it, and then allowing the doctors to practice beforehand. And it doesn't sound like a lot, but it's as easy as saying, oh, take a tape measure and measure that. And in the real world, like physical world outside of our bodies, we don't think too much about it. But in a medical surgery, like, you're opening up another human and you have to find the distance of a tumor. Being able to measure it beforehand and know where to cut can actually save anywhere from 20 to 40% of that surgical time. There is no measuring once you open up the person. It's here's the instructions, here's how much to take out. So that's why this, as silly as this is like, oh, you create a colorized model of what's inside of that person. Kind of, so what? The answer there is, well, no one could actually visualize it before. We didn't know where it was. We didn't know the shape. We couldn't feel it, touch it, or do it. Now we can. So this is opening up a lot of new avenues, in especially the medical field. So, and one of the things I wanted to touch on is how are we creating all these crazy new things, especially in the medical and with the animation? We're using this thing called voxel printing. It's still, I'll say, not quite in its infancy, but it's basically you're controlling each individual 3D pixel. And you're able to go slice by slice through your 3D prints and then create amazing, pieces of art. In the medical field, you're able to control what's support, what's Tango, what's Agilis, what's Vero, and you can create crazy strength, I'll say deviations from the normal. So we have stock, all right, that's going to have this shore value, but now you can take that same shore value and put a different pattern inside of it, how it lays it down, and it will act a completely different way. And that also allows you to do, mimicking the internals of bones and other densities that we couldn't do before. So that's something that also comes along with these big box printers. So with that, I want to thank you for attending. Let us know if you have any questions, and here for you to pick my brain.
Excellent. Thank you very much, Keith. Extremely informative. Don't believe I saw any questions. Well, everyone, I'm going to go ahead and wrap things up. I don't see any questions. Thank you all for attending. Keith, thanks for putting the presentation together, and I hope everyone has a nice rest of their day. So thank you very much.